Alright, so today we're going to look at solving systems of linear equations, or linear inequalities. This is section 6 of chapter 5. Basically, guys, we're just going to be building off of what you just did. So let's start with this warm-up. Number 1, 8x plus y is less than 6, and it says to solve each inequality for y. So with this one, all we got to do is worry about getting y by itself. Alrighty, so first thing we need to move is that 8x to the other side. So you just subtract 8x, move it over here, and now we rewrite what we have. Y is less than negative 8x plus 6. There's number 1 done for you. Number 2 is a two-stepper here. You got to start by moving that x first. So we subtract 3x, bring it to the other side. So you get negative 2y is greater than negative 3x plus 10. Next step is to get that y all by itself, in which case we divide by the negative 2. Everything gets divided by a negative 2. Okay? So this becomes y, and then remember, when we divide by a negative, we have to flip the sign. Negative 3 over negative 2 will just be a positive 3 halves, or 3 over 2x, and then 10 divided by negative 2 is negative 5. So the answer to number 2 should have been y is less than 3 halves x minus 5. Okay, so for number 3, just a quick refresher on the graphing side of these. Alright, the first thing is we still have to put it into slope-intercept form, which means y by itself. So let's start by moving the 4x to the other side. So then we'll have 3y is greater than negative 4x plus 9. Divide through by the 3. Okay, so then our inequality is y is greater than negative 4/3 x plus 3. So now we have to graph that. Let me write that down here real quick. Alrighty, so now we got to graph it. So what I'm going to do is I'm going to pull up some grid paper here on my Okay, so I've got some graph paper up here for you. Alrighty, so now we're ready to graph. Remember that that was y is greater than negative 4/3 x plus 3. Okay, so we take that plus 3, that's my intercept on the y, so we're going to plot a point on the 3. My slope is negative 4 over 3, so that means down 4, and then over positive 3. So right about here, if I can get my pen thing to write. Roughly right there. Okay, so now we have to connect our dots, but that's where we look at the symbol right there. And because it is not equal to, what kind of line am I going to have? We are going to have a dashed line. Alright, so let's get this dashed line on here. Alrighty, and this says y is greater than. So on what side of the line is it going to be greater than? Well, that is this section over here. Alrighty, so hopefully by now you guys are getting a hang of how to graph the inequalities, because today we're going to step it up and do systems of inequalities, which means we're going to be graphing 2 lines at a time. So let's go ahead and get busy with this section. Graph and solve systems of linear inequalities in two variables. So that's just what I was telling you. That's our objective for the day. Okay, some of the vocab: systems of linear inequalities in the solution of a system. Alright, so a system of linear inequalities, basically it's a set of two or more. We will deal specifically with just two in this class right now. And then the solutions of a system are all the ordered pairs that will satisfy or that will make those inequalities true. Alrighty, so let's jump straight into this example. Tell whether the ordered pair is a solution of the given system. Guys, we've been doing this. There should be no issue on how to do this stuff. Okay? If I'm giving you a coordinate point x, y, and I give you two different inequalities, you have to plug it into both, and it has to work in both to be the solution. So our first inequality, y is less than or equal to negative 3x plus 1. I'm going to replace y with negative 3. And then replace my x with a negative 1. So let's see if this holds true. Okay, negative 3 times negative 1 is a positive 3. 3 plus 1 is 4. So is negative 3 less than or equal to 4? Yes. So as of right now, the first one is good. We're doing good. Alrighty, so now let's check this other inequality here. So y is less than 2x plus 2. So negative 3, is that less than 2 times negative 1 plus 2? Well, 2 times negative 1 is negative 2. Add 2 onto that, and that gives you 0. So is negative 3 less than 0? Yes. Negative 3 is less than 0. So because this worked in both both inequalities, is that point negative 1, negative 3 a solution to the system? Yes, this is a solution. Now you can't just put yes or no. You see all that work that's on that screen? You're going to need that on your papers as well. Alrighty, so let's look at another example here. Negative 1, 5. And we're plugging that into y is less than negative 2x minus 1. And then y is greater than or equal to x plus 3. So let's check and see if these will work. Okay, so y, 5, is that going to be less than negative 2 times negative 1 minus 1? So negative 2 times negative 1 is a positive 2. 2 minus 1 is 1. So is 5 less than 1? No. So guess what? Because we found that no on that first attempt, you do not need to go through and do that other equation, or other inequality, excuse me there. Okay? We found our no, that means no, that coordinate point is not a solution. Okay, and then just a real quick note there. Remember that an ordered pair must be a solution of all of the inequalities to be a solution to the system. That's practically what I was telling you. It has to work in both of them in order for it to be an answer to both. Okay, so next up we are going to start looking at graphing a system. Alright, so instead of just graphing one inequality, we'll be graphing two of them. My colored pencils, like I said the other day, the colored pencils are very essential here. If you don't want to use them, I get that, but you're going to want to watch this, because when we start doing two different lines, the solution system is like the solution to the system is going to be where the colors would overlap. And it's easier to see with colored pencils. Okay. So here's an example as to what you might see I'm not going to explain this. I'll explain it as we go through an example here in a minute. Okay, so let's just jump into the first one here. Y is less than equal to 3. So let me see. Let me switch. Don't want that one. There we go. Alright, so my first inequality, y is less than equal to 3. So this one, you go to where y is 3. Okay. But this one, because there's nothing else, it's going to be a horizontal line here. But we have to look at this symbol here. What kind of line am I going to have? If it is equal to, that means I have a straight line. It's not dashed, it's solid. And you got to imagine here with me, this is really hard to draw on. Okay, that goes right through 3 on the y-axis. And now we have to shade. So on what side of that line, the top or the bottom, is y going to be less than or equal to 3? Well, if it's less than, then it has to be the bottom. Notice I'm going to color in this whole region. Okay, next up we have the other inequality, which is y is greater than negative x plus 5. Okay, so now let's start to graph this. We need to go to positive 5 on the y-axis. Get my starting point here. Imagine we're right there. Now we have a slope of negative x, well, which is technically negative 1. So that means I need to go down 1 and then right 1. Down 1, right 1, down 1, right 1. Okay, and then is my line solid or dashed? It's going to be a dashed line. It is not equal to. So we're just going to extend this in both directions. Now here comes the fun part of shading. Let me see if I can't get my color changed here real quick. Alright, so this reads y is greater than the line, basically. So on what side of that dashed line is it going to be greater than? Which side of it is the top? Well, it is this region all over here. So notice I shade that whole side of that entire line. Okay? Now, what you need to recognize is where the actual solutions are to this set of inequalities. Okay? Notice that this region here is just yellow. Notice this region here is just green. But notice this section right here is both yellow and green. That's where the shading is overlapped. That is the solution area to the inequality. So you can choose any coordinate point inside that blue triangle I just created, plug it in and solve it, and those inequalities will hold true. They will hold true. Alrighty, so let's go ahead and start another problem. So we'll clear that off my screen. We're going to go to this one. Okay, negative 3x plus 2y is greater than or equal to 2. So before we can do anything with that one on the graph, we've got to put it into slope-intercept form. So first things first, we need to move that at negative 3x to the other side. So when we do this, we get 2y is greater than equal to, I'm going to put it here, 3x plus 2